Let's do one more question on frequency modulation. Read the question. A sinusoidal carrier of frequency Fc is used for both AM and FM. Okay. So here we are considering both AM and FM. Carrier frequency is Fc and it is used for both AM and FM transmitter. Message signal is given by 5 kHz. That means frequency of the message signal is 5 kHz. The maximum frequency deviation is equal to 2 times the bandwidth of the AM wave. See here, it is not given directly. It is not given directly, right? Now it is said the delta F for this FM, which is also called as maximum frequency deviation, it is 2 times bandwidth. Now tell me, what is the bandwidth of AM wave now? Because here AM also involved here, and signal frequency is given. What is the bandwidth? 2 times the 5 kHz. Yes or no? Right? The bandwidth of AM is 2 times the 5 kHz. That is 2 times FM. So maximum frequency deviation is nothing but 2 times bandwidth. That's nothing but 10 kHz. Right? Maximum frequency deviation delta F is equal to 2 times the bandwidth of AM. That is 10 kHz. You got the value here. What you need to find out? Find the modulation index for both AM and FM such that strength of frequency component, okay, the strength of frequency component Fc plus 5k, see here, Fc plus 5k is same in both AM and FM spectrum. Same both AM and FM spectrum. See, now hope you remember, when the beta value is very less, the spectrum of AM is equal to spectrum of FM, right? Okay, so see, now it is said that, see, the modulation, find the modulation index of both AM and FM such that strength of frequency component, okay, in the spectrum you have this Fc plus FM. Fc plus FM. FM is 5 kHz, you know that. The strength of the frequency component Fc plus FM is same in both AM and FM. I have understood this. Okay. So what you have to do is, you have to find out, okay, see, this is coming in J1 of beta, right? J1 of beta. Beta value you can calculate. What is the beta value? Beta value is nothing but delta F divided by FM. Now use that beta value, okay, to find out what is that Bessel value, right? What is that Bessel value, right? You know that for narrowband frequency modulation, okay, you know that spectrum of AM is equal to spectrum of FM, right? You must be knowing it, okay. Now it said that it's same both FM and AM. So you have to use the same amplitude, okay, to find out the modulation index of the AM wave, right? Modulation index of FM wave will come directly, not a problem. But if you want to find out modulation index of AM wave, it is actually MAC by 2, right? Yes or no? It is MAC by 2. You have to find out that amplitude, okay, of the spectrum of the first sideband, that is Fc plus 5k, and then calculate the modulation index of AM. Okay, in this question modulation index of both AM and FM is asked. Modulation index of FM is direct here, it is delta F divided by the FM, but modulation index of the AM, to calculate, okay, you have to find out from the spectrum. In the spectrum, see what is the amplitude of the component Fc plus FM. That is, it is coming as something around beta into J naught of beta, yes or no, right? AC into J naught of beta, something like that, which you have seen in one of our class, right? Use that and solve the problem. Now let us see this. See, bandwidth of AM is, okay, 2 times FM 10 kHz. What is modulation index? What is beta? You have to calculate it, right? Now delta F is given, right? It is actually said that it is 2 times the bandwidth of the AM signal. It is bandwidth of the AM signal is here. So delta f is equal to 20 kilohertz. Beta you can calculate delta f by fm. Right now, if you want to calculate, okay, if you want to calculate the strength, okay, the modulation index of the AM wave, you have to find out from the spectrum. So for fc plus phi k, which is fc plus fm, what you have is AC by 2 J1 of beta. The whatever strength you have is AC into J1 of beta by 2. Now that is equal to MAC by 4 corresponding to AM wave. If you see the spectrum of AM wave and spectrum of FM wave, it is said that particular frequency component is same. That means MAC by 4 of the AM wave is equal to the AC J1 beta by 2 of the FM spectrum, that is narrowband frequency modulation spectrum. So compare these two. When you compare these two, what happens? AC will get cancelled, okay, and then you can see that there is some cancellation is happening. M is going to be J1 of 4, beta is 4, right? Okay, so from the Bessel table, find out what is M, which is equal to J1 of 4 into 2. Okay, from Bessel table, J1 of 4 is equal to minus 0.06660. M is going to be minus 1.132. This is the answer. Okay, so of course the modulation index is actually coming to be which is negative here. Don't worry, but just put the answer. I've understood this. Okay, so which is not the exactly if you take the magnitude spectrum, okay, of the AM wave, then it is going to be positive. Okay, don't worry, you put the answer as it is. Okay, this question you can solve by having a knowledge of narrowband frequency modulator. Okay, just go through whatever you have derived for narrowband frequency modulator and then you can solve this question. Read the question properly, understand the question, then you do it. Don't directly try to calculate with whatever formulas you know. Just check what is given and from there what is to be calculated.